Hello students, welcome to today's class. So before start of the class, I want to request you to subscribe to the channel and press the bell icon so that you get all the notifications about what is being taught in the class. So don't forget to press bell icon and subscribe to the channel. So stay inside, stay fit. We are winning the battle against coronavirus, and it is not only government's duty, it is not only the health officials' duty, it is the duty of the society. So as a member of the society, as a responsible member of the society, kindly follow the instructions given by the government, given by the health officials. So don't try to get out, keep inside, keep healthy, have light food and have good exercise, and read as much as you can. It is a golden time for you. You can study as much as you can, not only the school books, but you can also study extra books. And if you don't understand anything, you just click the paragraph or you just put on your views in the comment box. I will try to explain that is not understood. So thank you very much. Let us start with today's class. 10th class students, in today's physics class, we'll do some numericals regarding exercise 2b, numericals of exercise 2b, related to work, power and energy. The formulae that we have learnt, now we will use in numericals. So numerical 1, page number 41. Two bodies of equal masses. For body A, then body B, let mass be x. Here also we take mass as x because masses are equal. Here height is h, here height is 2h. We have to find the ratio of their gravitational potential energy. So GPE, here is mgh, here also mgh. Mass here is x into g into height is h. Ratio, here mass is x, g is same, the height is 2h. X cancel with x, g cancel with g, h cancel with h. It is 1 over 2. So ratio of their energies will be 1:2. It's very much simple. Second question. Find the gravitational potential energy of 1 kg mass kept at height of 5 meter above the ground. So mass is 1 kg, height is 5 meter, potential energy, gravitational potential energy is mgh. 5 into 1 into g is 10, it is 50 joule. Now when this stone is dropped from height of 5 meter to the ground level, potential energy changes into kinetic energy. From law of conservation of energy, from law of conservation of energy, this potential energy is equal to kinetic energy. This potential energy will change into kinetic energy. So kinetic energy is also equal to potential energy, that is 50 joule. Question number 3. weight is 150 kgf. Now value of G is 9.8. So when I change it into Newton, I multiply it with 9.8. I keep it. So weight is mg. I don't multiply 150 into 98 upon 10. So mg will be 1470 Newton. Now potential energy is given, that is 14,700 joule. Potential energy is mgh, that is 14,700 joule. Mg is 1470. H I have to find. Joule. H is upon 1470. This will get divided in the right hand side. So H is 10 meter. So remember, when I change kgf into Newton, I multiply it with value of G. Now value of G is 9.8. So when I change it into Newton, I have to multiply it with 9.8. If value of G is not given, then I have to multiply it with 10. I can multiply with 10. Then no problem. 4. A body of mass 5 kg falls from a height of 10 meter to 4 meter. So mass is 5 kg. Height is H1 is 10 meter. H2 is 4 meter. Loss in potential energy. Loss in potential energy is mg H1 minus mg H2. Mass is 5. G is 10. That mg I take common. Inside will be H1 minus H2. 5 into 10, 50. H1 is 10. H2 is 4. 50 into 6. That is 300 joule. Energy at any instant is equal to original energy, because when body falls, its potential energy decreases, but it is in motion, its kinetic energy increases. So total sum of energies remains same according to law of conservation of energy. So energy at any instant will be equal to original energy, that is mgh. Original height is 10 meter, so original energy will be 5 into 10 into 10. 5 is mass, 10 is gravitational acceleration due to gravity, h is original height 10 meter. So energy at any instant will be 500 joule. Question number 5. Calculate the height through which a body of mass 0.5 kg. Question number 5. Mass is 0.5 kg. Is lifted if the energy spent in doing so is 10 is equal to 1 joule. So G is 10 meter per second square. Potential energy change is 1 joule. Height we have to find. Now potential energy is one joule mgh. Potential energy is 1 joule. mgh is 1 joule. Mass is 0.5 kg, mean 5 by 10 kg. G is 10, it is given. H I have to find. 1 joule, so 10 cancels with 10. H is 1 upon 5, that is 0.2 meter. So height will be 0.2 meters. Question number 6. A boy weighing 25 kgf. Now in this question, G is 10 Newton per kg. So weight is 25 kgf or 25, as G is 10, it is 250 Newton. mg is 250 Newton. Climbs up from the first floor at a height of 3 meter above the ground to the third floor height of 9 meter above the ground. What will be the increase in his gravitational potential energy? So final height is 9 meter. Initial height is 3 meter. So change in potential energy. mg final height minus initial height. mg is 250, final height is 9, initial height is 3. So 250 into 9 minus 3, 6. It is 1500 joule. That will be change in his energy. So when he climbs from 3 meter to 9 meter, 6 meter height he covers. For that height increase in energy spent is 250, that is mg into h, 1500 joules. Question number 7. A vessel containing 50 kg of water is placed at a height of 15 meter. So mass is 50 kg, height is 15 meter, G is 10 meter per second square. So potential energy is mgh, mass is 50, h is 15, g is 10, that is 7500 joules. So no problem here, easier one. Question number 8. A man of mass 50 kg climbs up a ladder of height 10 meter. So do it yourself. Question number 8 is your homework. Same question. Question number 9. A block A weighing 100 Newton. Question number 9. A block A its mass is weight is 100 Newton. This is 3 meter. Is pulled up a slope of length 5 meter. This length is 5 meter. by means of a constant force F equal to 100 Newton. What is the work done by the force F in moving the block A 5 meter along the slope? So work done is Fs. Work done by pulling along the slope. Now force is in the direction of slope. So cos theta, that is Fs cos 0, because pull is in the direction of work done. Force is 100 Newton. Distance is 5. Cos 0 is 1. So it will be 1 meter. 500 Newton meter mean 500 joule. So work done in for part A will be 500 joule when 100 Newton force is applied to pull the block by distance of 5 meter, because force is in the direction of the pull, so we take theta as 0. Second, what is the increase in potential energy of the block? Part B. Now the block gains height 3 meter. mg is 100 Newton, because 100 Newton is mass of the weight of the block, that is given. So increase in potential energy is mgh. Mg is 100 Newton, h is 3. So increase in potential energy is 300 joule. 100 Newton into 3 meter, 300 Newton meter or 300 joule. Question number C. Now question number 9, part C. Account for the difference in the work done by the force and the increase in potential energy of the block. Now difference in energies is 500 joule minus 300 joule, that is 200 joule. Work done on the block is 500 joule. Increase in energy is 300 joule. Now question arises where the extra 200 joule are spent. The difference is 200 joule. The work done on the block is 500 joule, but increase in energy is not 200 joule. 500 joule. It is 300 joule. So where is the difference 200 joule go? It is spent to overcome the force of friction. So 200 joule is spent to overcome the force of friction. That is all for today. Tomorrow we start from question number 10. So until then, stay fit, stay healthy, stay inside. Thank you very much. Bye bye.